Our problem is a poster is designed to have a total area of 180 square inches. The poster should have a 2-inch margin at the top and 1-inch margins at the bottom, and on each of the right and left sides. So calculate the dimensions that will maximize the area of the printed material, and everything else is just directions. So with that said, we'll get into OneNote here and get after it. Okay, so I mean, what's really the information that they gave us first is that our total area is going to equal 180 inches squared, of course. What formula is going to get us that? So from geometry, we know that the area equals the length times the width. That's really all we need as far as equations go for now. So we can go ahead and draw our diagram. And we got our poster here. Okay. And what did it say? We'd say we had a 2-inch gap at the top, 1-inch gap here, 1-inch gap here, and 1-inch gap here. Okay, so we'll draw our secondary rectangle. That's messy. That's not going to be acceptable. So we'll go here, here, come over, here, and here. Okay, we've got our secondary rectangle here. So how do we solve this problem? What's the overall steps? Well, we don't have the dimensions for this, so we need to find an equation for this with relation to x and y. Set that equal to make that a one variable equation. So set really x equal to y, and then plug that in to our length times width equation, and then keep going from there. Sorry, I spaced out there for a second. So I'm not going to explain the whole thing. I'll explain as I go. First, so we know, this will be x. We'll set this outside equal to y as our length and our width. So we know x times y equals 180. All right. So let's go ahead and set this equal to y, because that's what I'm more comfortable with. But you can set it equal to x if you wanted to. So now we have y equals 180 of x. So how does that help us? So we don't have the dimensions of the inside, but we do know that so we're missing 2 inches off the sides here. So we can actually call this down here x minus 2, and we're missing 3 inches here at the on the top side, so we can call this y minus 3. And we don't know the area, but it's not gonna matter right now. So we can reset this up. Y minus 3 times x minus 2 as our length and our width is going to equal our area function, area of x, or area with respect to x. And this is where this comes in, right? We got y equals 180 of x, so we can plug that in here. 180 over x minus 3 times x minus 2, and that's going to equal our area function. Great. All right. So what's the next step here? Well, we want to take the derivative of both sides of this equation and set that equal to 0. That'll give us the critical points of our rectangle here, which is the maximum and the minimum value. So that's going to give us that's the eraser. That's not what we want. That's going to give us like here to here and here to here. That's going to give us those lengths, right? So it's going to give us the sides. It's going to give us the sides that we want. But before we do that, we're going to have to FOIL this out here. So the first term is 180x over x. I'll get it go. Outside, negative 360 over x. Inside, minus 3x. Outside plus 6 equals the area of x. Okay, and we can further simplify this, but right off the bat, we see that this x is here. Go ahead and cancel that out. And now we have 180 plus 6 is 186, so we'll go ahead and write that. And then if we're going and actually right here we can take, this will be enough to take the derivative. So I'm actually going to bring this up into the numerator and just call it x minus 1. So x to the negative 1 minus 3, x plus 186 equals our area function. All right, so we're good to take the derivative here. And we'll start with the smallest number, that's going to be 0. And take this x out, so that's minus 3. And then we've got, oh, this is negative. Yeah. And then, so we're going to do the power rule here. And that's going to make this is essentially negative 1. Times negative 1 is 1. And then this is going to be subtracted by 1. And so now we're going to have positive 360x to the negative 2. And this is going to equal a prime of x, the derivative of our area function. All right, so going forward, this is going to go back into the denominator. 360 over x squared minus 3, and this is going to equal our area function. Great. So we're good to go here. We can set this up. We can set this equal to 0 and find our critical points, our maximum value, our maximum max value. So let's just go ahead and do that. Equals 0. 360 x squared. All right. So just basic algebra here. Adding 3, multiplying by x squared. Oop. Oh, that's weird. X squared. So now we got 360 equals 3x squared. Divide this 3 back over. It's going to give us 120 equals x squared. Now I have a calculator to take the square root here and the x, and I'm going to run it to 3 decimal places, and it is 10.954. You could do it without a calculator, but it's a lot easier if you have one, so I'm using that. All right, so this gives us our maximum max value. So we're going to go back up to the top here, and we're going to bring this function back over. Our 180x, our basically our y minus 3 and x minus 2 with y substituted. And we're going to plug in what we know now. So now we've got 180 over 10.954 minus 3, and then 10.954 minus 2, and that's going to equal our area. And from here we can just go ahead and solve for, and the question wanted our dimensions, so we'll go ahead and give them that. 8.954 is going to be our width, equals the area of x, and this is 180 divided by 10.954 is 16.432, and you subtract 3. Actually, you know what? So let's. I'm gonna go ahead and write this up just because it's good to know. The 10.954 is our x value, and 432 is our y value. That's not what it asked for, but that's always good to know in a problem like this in case you got to go any further. We don't, but in the future you might. We've got 13.432, and that is just this right here, times 8 point. Okay, so this is our length and width, and so our width is equal to 8.954. Our length is equal to 13.432, and we can multiply those together, and our maximized area is going to be 120.273. And so this is our answer here, and I hope I enjoyed teaching it. And let me go back. I hope I explained everything properly, and I enjoyed teaching it, like I said, and I hope I got the right answer. So have a good evening.